And welcome back, students. As we continue talking about text files, let's today discuss reading a text file using BufferedReader. Now, of course, if you recall before, we used the scanner class, but today we're going to be using BufferedReader. It's another approach, very similar, but again, slightly different. So, until the scanner class had actually been introduced in version 5.0 of Java, the class BufferedReader was the preferred stream class to use for reading from a text file. Now, it is still commonly used for reading from a text file. So just because scanner exists doesn't mean that BufferedReader doesn't exist. Now, the use of BufferedReader is illustrated in our text file input demo, which contains a program that reads 2 lines from a text file named morestuff2.txt and writes them back to the screen. File morestuff2.txt is, of course, a text file a person could have created with a text editor, such as Notepad, or that Java program could have created using PrintWriter. All right, if we jump over to that program right here, you can see we have our new IO right here, BufferedReader. And you'll notice, unlike Scanner, remember Scanner is part of java.util, this is part of IO. So right here is BufferedReader. And very similar, you'll see that here we say try BufferedReader, input stream, new BufferedReader, new buffered morestuff2.txt, string line, input stream.readline, then first line of ref text file is this, print the line equals input stream.readline. The second line from the text file is system print line input stream.close. Of course, then we have our two catch statements right here for our file not found and IO exception. So, for example, if I run this program as is, we get the first line from the text file is 1, 2, 3. The second line run from the text file is going to be Jack jump over. Last lines I think are the candlestick. Right, just very simple lines here. So you can see that there's some slight differences. For example, everything here is inside of this try block. There's nothing outside of it. So it's a very similar to how we looked at stuff before. For example, let me just bring up the scanner demo here so we can kind of see these things side by side. You'll notice here the scanner input stream equals null is outside of the try block, whereas here our try block is the input stream itself. So there's some slight differences between how you handle these two classes. However, they ultimately can do the same thing. So let's just kind of analyze this a little bit and talk about how to open a file. Now the program opens the text file morestuff2.txt as follows: BufferedReader input stream equals new BufferedReader, new file reader morestuff2.txt. The class BufferedReader, much like our classes PrintWriter and Scanner, has no constructor that takes a file name as its argument. So we need to use another class, in this case the class FileReader, to convert the file name to an object that can be an argument to that of BufferedReader. Additionally, you'll notice that we talk about readline here, an object of the class BufferedReader that is connected to a text file, as in text file input demo, has a method named readline that is like the method nextLine of the Scanner class. So they're very similar in that regard. Now, this use of readline is to read a text file that is illustrated within our text file input demo. You'll notice there's only two methods for reading from a text file, though: readline and read. All right, and there is some advantage to that and also some disadvantages. Now, opening a text file for reading with BufferedReader. All right, if we want to create a stream of the class BufferedReader, connect to a text file for reading as follows. The general syntax is BufferedReader stream object is equal to new BufferedReader, new file reader file name. So, of course, we can reference that back to our example of BufferedReader input stream, new BufferedReader, new file reader, morestuff2.txt. Now, after you've created that statement, you can then use the methods readline and read in order to read from the file. When used this way, the file reader constructor, and hence the BufferedReader constructor invocation, can throw a file not found exception, which of course is a type of file IO exception. Because IO means input output, and file not found just means it can't find the file. It's looking for morestuff2.txt. It doesn't exist where it's looking. All right, so you want to make sure if you're putting the file in there, you're putting it in the correct location that Java can access it. All right, now read is of course different from that of readline. The method read only reads a single character, whereas readline is going to read obviously a line of characters. Now, note that read returns a value of type int that corresponds to the character read. It does not return the character itself. Thus, to get the character, you must use a typecast, as in char next equals char input stream dot read. If input stream is in the class BufferedReader and is connected to a text file, this will set next equal to the first character in the file that has not yet been read. You'll also notice that the program in text file input demo catches two kinds of exceptions, file not found and also I/O. An attempt to open the file may throw a file not found exception, and in the implications of input stream.readLine may also throw an I/O exception, right, because it may not be able to process it properly. Now, because file not found exception is the type of I/O, you could only use the catch block for the I/O exception because technically it is the type of I/O. However, if you were to do this, you're going to get a lot less information than if the exception was thrown. So by putting file not found in there, it tells us more specifically, hey, the I/O exception is that there was no file, not just, oh, there's an I/O exception. By putting the file not found in there, it makes it a lot more specific. If you only use one catch block and the exception is thrown, you'll not know if the problem occurred when you were opening the file, which is what file not found is done, or when reading the file after it's opened, which is what your general I/O exception is more designed to do. Now here's a quick tip for you. If you're reading numbers with BufferedReader. Now, unlike the scanner class, the class BufferedReader has no methods to read a number from a text file. You must write your code to read the number as a string and then convert the string to a value of numeric type such as int or double. In order to, you have to parse the number. So to read a single number on a line by itself, read using the method readLine, and then use integer.parsend, double.parsend, or some similar method to convert that string to that of a number. And now if there's multiple numbers on a single line, read the line using readLine, and then use the string tokenizer class to decompose the string into tokens. So for example, if we go back and look at our method here, when we called this string in here, if I wanted to look at this line over here of 1, 2, 3, I would have to tokenize that string, or I'd have to use a read call instead of readLine in order to break that apart to really kind of find what those numbers are. And the nice thing is a scanner class, scanner guy can look at that and say, hey, I can just do not next int, and I'll get 1, I get 2, I get 3. With BufferedReader, you don't quite have that advantage. Of course, then you use integer.parsend or some method to convert each token to number. So once you've processed everything in, convert it over, then you can use it as you normally would. So BufferedReader, is an old way in this. A lot of times you'll see scanner used now instead of BufferedReader because you don't have to parse it over because it automatically knows to convert it because it's looking for a next int or a next double. The advantage of something like this is if you're just looking for to just process in a string and you're not caring about if it's a number or not, BufferedReader might be a faster or more efficient option. All right, but that's going to wrap it up for today, folks, and we will